All right, this lesson is on exponents, and we are going to be multiplying some monomials. And a monomial is just something that has one piece to it, one term to it. So like 2x squared, that's a monomial. X to the fourth, that's a monomial. But something that has two pieces to it, like 2x to the fifth plus 4, now that's called a binomial. So all we're going to be working with today are monomials. They just have one term, and we're going to be specifically looking at the exponents. Okay, so the definition of an exponent. An exponent is a small superscripted number that shows how many times a symbol or a number is to be multiplied. So for example, 2 to the third, 3 is the exponent, and it tells me how many times I'm supposed to multiply the 2 times itself. So it's telling me to take the 2 times itself 3 times. So that's the purpose of an exponent, is to tell you how many times that you're going to multiply the number underneath it by itself. Okay, we actually have terms for some of these words. The number under the exponent is the base, so 2 is the base. So in this one, the number under the exponent, that's the base, so x is the base. And then the exponent is the superscripted number, so 4 is the exponent, and in this one, 5 is the exponent. And then sometimes we have, let's just write it over here, we have a coefficient. So the number in front of everything, the 3, that's called the coefficient. And then x, that's the number under the exponent, so x is the base. And 6 is the exponent. Okay, so we have some rules about exponents, and our first rule is that anything raised to the 0 power is 1. So 4 to the 0 power, 1. 1020 to the 0 power, 1. X to the 0 power, 1. Z to the 0 power, 1. So anything raised to the 0 power is 1. Okay, if something is raised to the first power, you get whatever the base is. So x to the first power is x. 2 to the first power is 2. 10 to the first power is 10, etc. So anything raised to the first power is whatever that base is that you started with. Okay, and then this next one is talking about what I mentioned a minute ago. So if I have x to the fourth, that means that I am supposed to take the x times itself 4 times. If I have 3 to the fifth power, that means I'm supposed to take 3 times itself 5 times. So the exponent tells you how many times to multiply the base by itself. Okay, another rule. To multiply two powers that have the same base, so let's talk about what I mean by that. If I have x to the fourth times x to the third, both of these have the same base. Remember the number under the exponent, that's called the base, so they both have a base of x. So whenever you're multiplying two powers together that have the same base, we add the exponents. So this would equal x to the seventh, because I add the 4 and the 3. And basically, because I have 4 x's here and 3 x's here, so that's 7 total x's. Okay, in order to make sure our answer is simplified, we have to make sure that we only see each base once. So I couldn't leave it like this because I see the same base twice. I have to make sure I simplify it if I can. And then if I have any fractions, I need to make sure that they're in simplest form, that they're reduced all the way. Okay, let's just practice a bunch. All right, starting with number 1. I see my parentheses are smushed together, So I'm multiplying. I'm going to start by multiplying my coefficients. So how much is 3 times 4? 12. Then I multiply my ends together. And we just learned a second ago that if you're multiplying the same base together, you add the exponents. So 2 plus 4 is 6. So it's n to the 6th. And that's our answer. Number 2. My parentheses are smushed together. So first I'm going to start with my coefficients. Negative 3 times 5 is negative 15. Then I go to my a's. So as long as I have the same base, I add the exponents. This a here has an exponent of a 1. You just don't see it. So if I add the 2 and the 1 together, I get a to the 3rd. Then I do my b's. So I'm multiplying the same base together, so I add my exponents, and 3 plus 4 is 7, so I get b to the 7th. And there it is. Okay, now number 3, switch things up a little bit. Number 3, I'm not multiplying, I'm adding. So this takes us back to stuff we learned a long time ago. Whenever you're adding like terms, all you add are the coefficients. So 1 plus 1 is 2, and then whatever the variable part is, that just recopies. So the answer is 2x squared. So let's stress something here. When you're multiplying, when you're dividing, your exponents will end up changing. Whenever you're adding or subtracting, whatever you started with is what you're going to end with. And you only get to add or subtract as long as they're like terms. So they have to be the same letter with the same exponent. So I can multiply things if they're not like terms. I can divide things if they're not like terms, but I can't add or subtract things unless they're like terms. Okay, so exponents, they're only going to change when multiplying and dividing. If you're adding and subtracting, do not change the exponents. Looking down here at number 5, I'm trying to add. But do I have like terms? I don't have like terms, so I can't simplify number 5. It is already simplified just the way it is, so that will be my answer. Now, I can multiply them, but I can't add or subtract them. Okay, let's come over to number 4. Number 4 is like number 3, except for I'm multiplying. So when I'm multiplying, as long as I have the same base, I add my exponents, and 2 plus 2 is 4. So when multiplying, you will add your exponents. When you're adding, whatever you start with, you end with. Okay, number 6 is like number 5, except for I'm multiplying. So I'm going to start with my coefficients. This one has a coefficient of a 1, you just don't see it. So 2 times 1 is 2. And then when I go to multiply my x's, I add my exponents, and I get x to the 7th. So I can multiply things that aren't like terms, but I can't add things that aren't like terms. Okay, number 7, I'm distributing on this one. So I take 2ab times ab. So remember, this has a coefficient of a 1, you just don't see it. So 2 times 1 is 2. A times a is a squared. B times b is b squared. Then I take 2ab times the negative 3, a squared b to the 5th. So I start with my coefficients. 2 times negative 3 is negative 6. Then I work the a's. A times a squared is a to the 3rd, because I'm adding exponents. B times b to the 5th is b to the 6th, because I'm adding exponents. And then I can't do anything else with this because these aren't like terms, and you can only subtract if you've got like terms. Okay, number 8. First, I'm going to multiply my numerators together, and then I'm going to multiply my denominators together. So let's start with the numerators. First, I want to take 20 times 12, and 20 times 12 is 240. Then I multiply my x's, and I add the exponents, so x to the 5th. Then I multiply my y's, I add the exponents, so y to the 6th, over. Now let's multiply our denominators. 3 times 5 makes 15. And then I just want to see if I can simplify 240 by 15. And so I just tried in my calculator. I took 240 divided by 15, which does make a pretty little 16. So the answer is 16, x to the 5th, y to the 6th. And now we're done. Okay, number 9. This has no multiplying in it. It's just adding and subtracting like terms. So I'm going to start, here's a 5x cubed. I look for some other x cubes. So remember, this has a 1 in front. So 5x cubed plus 1x cubed, that makes 6x cubed. So when adding and subtracting, do not do anything with the exponents. Okay, here's a y. Do you see any other y's? Nope, so I'm just going to recopy the minus 7y. Here's an xy. Do you see any other xy's? Yep, here's an xy, so I can combine those. So 8xy minus 3xy is 5xy. And then the guy in the back is a y to the 5th. Do you see any other y to the 5ths? Nope, so I just recopy it. And that is as good as it gets. I can't add or subtract any of these because none of these are like terms. So adding and subtracting, do not change a thing with the exponents. Okay, number 10. This is this strange shaped figure. So I am going to try to find the perimeter of all of it, and then I'm going to find the area of all of it. So perimeter, I just add up all my sides. Okay, so let's talk. If this bottom piece has a length of BC, this top piece will have a length of BC. If this has a length of 4BC, this bottom piece will have a length of 4BC. Now, I need to figure out this piece right here. So let's talk about that. If this whole thing is BC, 5BC, and this is 1BC, and this is 1BC, how much would this right here be? 3BC. Because the 3BC plus the BC is 4BC, plus the other BC is 5BC. Okay, perimeter, I add up all my sides. So I'm going to add the 3BC to the 4BC to the BC to the BC to the 5BC to the BC to the BC. So I'm just going to start writing it down. 3BC plus 4BC plus, and I'm going to put a 1 in front of that BC, plus another 1 BC, plus this 5 BC, plus this BC, I'm going to put a 1 in front of it, plus this other BC, I'm going to put a 1 in front of it, plus this 4 BC. Since all of these are BC, they're all like terms, and so all I have to do are add my coefficients. So 3 plus 4 is 7, plus 1 is 8, plus another 1 is 9, plus 5 is 14, plus 1 is 15, plus another 1 is 16, plus 4 is 20. So the answer here is 20BC. And that's the perimeter of my shape. Okay, now area, I'm going to find the area of this piece, and then I'm going to find the area of this piece. So let's start with the area of this piece. Since it's a rectangle, I do take my base times my height, or my length times my width. And so what is 4BC times 3BC? 12B squared C squared. Because you take the 4 times the 3, which is 12. When you multiply your B's, you do add the exponents. 1 plus 1 is 2. When you multiply your C's together, you add your exponents, and 1 plus 1 is 2. Okay, now I need to figure out the area of this rectangle right here. So I'm going to take the length times the width, or the base times the height. So that's got a 1 in front, you just don't see. So the area of this guy, 5 times 1 is 5. B times B is B squared. C times C is C squared. And so if I want to know my total area, I'm going to take the area of this piece, which is 5B squared C squared, and add it to the area of this piece, 12B squared C squared. And then are these like terms? They are. They're both B squared C squared, B squared C squared. So I can add these. So all I do is add my coefficients. 5 plus 12 is 17. The B squared C squared just follows. And that's the area of my shape. That's all she wrote, folks. Thank you. Smiley face.